All right, so today we're going to look at multiplication, division, and simplification of surds. So let's start with the multiplication rule of surds. And that very simply states that if we have the square root of a number and we multiply that by the square root of another number, we can simplify and express that as the square root of the product of the two numbers. So in the same way, if we have the square root of some number, it can be expressed as the square root of the two factors or two factors of this number. Okay, let's look at some simple examples. If we're asked to simplify the square root of 3 multiplied by the square root of 5, then quite simply we can use the multiplication rule and we can multiply the two numbers together, and this can be simplified as the square root of 15. Now the important thing to note here is that 3 and 5 were both prime numbers. Okay, let's take another example. Let's take an example where we have the square root of 8 and that is squared. Now there are multiple ways of looking at this, so let's think of it using the simple multiplication rule in the first way. So this can be written as the square root of 8 times the square root of 8. Square root of 8, so we can multiply the two numbers together, which is basically going to give us the square root of 64. And we know that the square root of 64 is 8. Now an alternative way of looking at this, an important thing to remember, is that the square root of a number, right, so the square root of 8 can actually be written as 8 to the power of a half, okay? And we are taking that and we are squaring that. So when we raise a power to a power, we can multiply the bases, so we'll get a half times 2, which gives us 8 to the power of 1, which is just 8. So using our laws of indices, we can arrive at the same answer. Okay, let's look at another example. Let's say we have 2 square root of 5 and we multiply that by 3 square root of 3. So what we're going to do is we're going to treat the numbers that are not under the surd, and then we're going to treat the surd and we're going to combine them together. Now again, the important thing to note here is that both the numbers under the square root are prime numbers. So 2 times 3 is going to give us 6. And 5 times 3 is 15, and we can combine those and we'll get 6 square root of 15. Okay, sometimes we need to expand and then simplify. So if, for example, we're given 4 minus the square root of 3 squared, and we're asked to expand and simplify this out. So 4 minus square root 3 squared can just be written as 4 minus square root 3 times 4 minus square root 3. So now we need to use our simple distribution when we're expanding out. So first, outer, inner, last, right? Alternatively, if you can think of these here perhaps like a variable like x, we can see that this is a simple expansion. So let's treat all the terms separately. So we'll get 4 times 4, which is 16. Then the outer term will give us 4 times minus square root 3, which is going to give us minus 4 square root 3. The inner will give us minus 4 square root 3. And then very importantly, we have the square root 3 times negative square root 3 times negative square root 3. And so we'll just get 3. So from here, we can just simplify. So we can add 16 and 3. We'll get 19 and minus 8 square root 3. So there we have expanded and simplified. Well, we can also sometimes not get simple ones. Say we get the square root of 3 plus 5 times the square root of 2. And that gets multiplied by the square root of 2 plus the square root of 3. So again, we can go first, inner, outer, last to expand the brackets out. We're going to get the square root of 3 times the square root of 2. Using our rule, we're going to multiply the numbers together. So we're going to get the square root of 6. Then we'll do the outer, so that's the square root of 3 times the square root of 3 and the square root of 3 times the square root of 3 is just 3. Then we'll do the inner. So the inner is going to be 5 times the square root of 2 times the square root of 2. So the square root of 2 times the square root of 2, the roots are going to cancel out and we're going to get 2. And then we're going to have 2 times 5, and so that will give us 10. And finally we have last, so we'll have 5 square root of 2 times 3, or square root of 3. So we can multiply the coefficients in front of the surd, which is just 5 times 1. And then we can use the multiplication rule to add or multiply these two together. So we get 5 squared, 6. All right, once again, we can just simplify. So we'll get 13 plus 6 square root 6 as our simplified answer. Right, one other important thing that we need to remember is that this rule can be applied backwards. All right, so as I said, if we start off with a number like 98, and we are asked to simplify this using the multiplication rule, right? You might think that this is simplified. However, the important thing to remember is when we looked at all these other examples, all the numbers underneath the original surds were prime numbers, meaning that there were no other factors. And if we look at 98, 98 is not a prime number, and so it can actually be simplified further. We actually learned this in IGCSE. You would have expressed these as prime factors, and then you could have pulled the prime factors out. Alternatively, we can think, well, what number... We can have a guess at what numbers might make up 98, and you can think, well, 49 times 2 makes 98. And so using the reverse multiplication rule, we can say, well, square root of 98 can be expressed as square root of 49 times square root of 2. Right? So if we had to go in the opposite direction, 49 times 2 would then give us 98 again. Now, the square root of 49 can be simplified as 7, and we have the square root of 2. And so we can simplify the square root of 98 as 7 square root of 2. Now, the way you would have done this at IGCSE, we would have expressed this as prime factors. So we would have started with 98, we would have divided by 2. And we would have got 49, and factor, or the next lowest prime number that can go into 49 is 7. That would have given us 7, and finally 1. So we could have seen, when we are taking the root of a number, we can pull out pairs of numbers, right? And then we would leave anything that was remaining. So this would have been expressed as 2 times 7 squared, and remember we were taking the square root of that. And as a final example, let's take the square root of 75 minus the square root of 12. Okay, now both of these numbers are not prime numbers, and so we can already work out that these can be simplified into 2 different factors. So again, if you can use some intuition, you can do this intuitively, or you can break the numbers down into their prime factors and solve them easier. So I already know that the square root of 75 can be expressed as the square root of 25 times the square root of 3. And here I'm going to subtract, and I'm trying to think of another perfect square number. And I can think, well, this can be expressed as the square root of 4 times the square root of 3. And so we can simplify this as 5 square root 3 minus 2 square root 3, and the simplified answer would then be 3 square root 3. Now, just like multiplication, we can also divide. There's also a similar rule when we are dividing surds. So if we have the square root of some number divided by the square root of another number, this can be expressed as the square root of these two numbers. So we can again work this backwards, where if we had these two numbers under the surd, we could split them up into their two different factors. So let's just look at one simple example to finish off. So we have the square root of 77 divided by the square root of 11. Now 11 is a prime number, 77 is not. And so what we could do is we could express both of these as their prime factors. Alternatively, we can first combine these as the square root of 77 over 11, which we can simplify, and we will get the square root of 7, right? And again, 7 is a prime number, so we know we can't simplify this any further. We can't pull anything out.